Hello everyone, welcome to TNT for NEET. Today we will discuss about friction. So without wasting time, let's get started. First we will tell the properties of friction and then in another video I'll tell you how it is applied. The first point is friction is always opposite to the motion. Means if there is an object and this is the surface which is rough, so if the object move on this side, then the friction force always in opposite side. The second point is in sliding friction all the components are opposite and parallel to the velocity. This is the sliding friction, means there is a block and this is the rough surface. So if the block move on this side, velocity on this side, so the sliding friction all the components are opposite and parallel to the velocity. These components are opposite and parallel to the velocity. In rolling friction, all the components are opposite but not parallel to the velocity. In rolling friction, all the components are opposite but not parallel to the velocity. Means if there is a wheel and there is a rough surface, so the components are these and the velocity is in this direction, but all components are not parallel to the velocity. They are opposite but not parallel to the velocity. The next point is friction force depends on the roughness of surface, called coefficient of friction. Means there is a surface, this is the surface and this is the block. So the roughness of the surface is called coefficient of friction, that is mu. The mu is unitless, means mu have no unit. The next point is friction force doesn't depend upon cross section area. Friction force doesn't depend upon the cross section area of the object. As we decrease the roughness of the surface, the coefficient decreases, mu decreases as we decrease the roughness of the surface. As we decrease the roughness of the surface, friction coefficient decreased, but after the limit of surface finish is crossed, means if the surface is highly finished, then the coefficient of friction get increases. If the surface finish is too high, means roughness is very low. When the roughness is very low, is cross the finishing, surface finishing. After the limit of surface finish is crossed, the coefficient of friction get increases. due to between two bodies a bond is generated. Means this is a body and this is the surface or another body. So because of high finish there is bonds are formed, because which the friction is increases, the coefficient of friction increases. For example goes to, if there is an ice cube and a wooden block, ice cube, wooden block, there is an ice cube and another ice cube. If there is a wooden block and an ice cube, there is a wooden block and there is an ice cube, and the fourth condition is there is a wooden block and there is another wooden block. So where the coefficient of friction is maximum, there is mu1, mu2, mu3 and mu4. So where the coefficient of friction is maximum and where the minimum. So for this I'll already tell you that where the high finish of the surface is, the coefficient of friction is maximum, means the ice cube is have high finishing and another ice cube is high finishing. So between these two ice cubes bonds are formed. So mu2 have maximum coefficient of friction, and then these two wooden blocks both are rough, so it have the maximum coefficient of friction. And in these both case, ice cube and wooden block and ice cube, in both cases the coefficient of friction is same. So like this, in ice cube and ice cube the bonds are formed, so the coefficient of friction is maximum. In next video we will talk about limiting friction, dynamic and static friction, etc. If you want to that your concept will be crystal clear, so please watch the full video till the end. Hope all of you trying your best. All the best. Thank you.